17, Exam 1, Recursion and Financial Modelling. The value of the reducing balance loan in dollars after n months can be modelled by this recurrence relation. Initial value is 26,000. The next term is 1.003 times the current term minus 400. What is the value of the loan after 5 years? We're going to use our recurrence function on our calculator. So I'm going to type in the original amount, which is 26,000. Press enter. That's my initial. My rule says 1.003 times the current minus 400. So I'm going to press times and it'll say the previous answer. 1.003 minus 400. Enter. So I have initial, end of year 1, and now I just need to keep pressing enter. End of year 2, end of year 3, or month 3 I should say, end of month 4, end of month 5. So my answer is 24380 and 31 cents. And there it is. The first 5 terms of a sequence, 2, 6, 22, 86, 343, the recurrence relation that generates this sequence could be. So you just have to use a bit of trial and error and work out which one it is. They all have initial value of 2, so we can't eliminate any. Plus 4, so that works plus 4, but certainly not there. And you just go through them and see how it works. So 2 times the previous value, so 2 times 2 is 4, plus 2 is 6. That works there. Let's try it again. 2 times 6 is 12, plus 2, no, 14, no. 3 times the previous, yes. 3 times 6, no. 4 times the previous minus 2, so 8. So let's try this one. 4 times 6, 24, minus 2, 22. 4 times 22 is 88, minus 2, 86. I think it's going to be D. And we check E, and E doesn't work either. Shirley would like to purchase a new home. She will establish a loan for $225,000 with interest charged at a rate of 3.6% per annum, compounding monthly. Each month, Shirley will pay only the interest charged for that amount. After 3 years, the amount that Shirley will owe. Oh, she's only paying the interest. She's never paying any off the principal. So she owes $225 after 3 months. Wait, is that it? After 3 years, she's still going to owe $225. So the answer is C. They're checking whether you're reading the question. Interest only. Let Vn be the value of Shirley's loan in dollars after n months. A recurrence relation that models this value is. Okay, remember she's paying interest only. So her initial is $225. Okay, she has to pay interest. She's paying that off. So we can get rid of these straight away because there's no payment there. That's just like going up, 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 up. So she has to pay some interest off. And so now I'm looking at these. I've got 3.6 per annum. I want the monthly rate. So I'm going to do 3.6 divided by 12. So that equals 0.3. So R equals 0.3. So R, capital R, 1 plus 0.3 over 100, 1.003. So I can get rid of that one. So I've got rid of 3 already. Okay, so it's either C or D. Now the money she's paying back is just the interest, 8,100. That's going to be too much interest. So I'm going to guess it's D. But let's just check. We have to work out what the interest is. So she's paying 0.3% of 225,000. So 0.3 over 100 times 225,000. Put that in my calculator and 675. So she's paying 675 interest per month. So D. Printer was purchased for 680. After 4 years, the printer has a value of 125. On average, 1,920 pages were printed every year for those 4 years. The value of the printer was depreciated using unit cost method. The depreciation in value of the printer per page is closest to what? So we have to work out total depreciation so far. So 680 minus 125. So the printer depreciated $555 over the 4 years. How many pages were printed in 4 years? 1920 times 4 equals 7,680 pages were printed. So it depreciates $555 and 7,680 pages were printed. So what is the value of the printer per page? So we're going to do 555, the amount depreciated, divided by the number of units it did, which was 7,680. It's 0.0722, that's a 0, which equals 7 cents per page. So it depreciated 7 cents per page. So E. Right, consider the graph below. Have a look at your graph. It is going down. It is a geometric decay. Okay, you have got your graphs in your bound reference, so you should look at that. And I've told you geometric decay is a reducing balance loan. So let's read our choices. A piano depreciating at flat rate. No, flat rate would give you a straight line. A car depreciating with reducing balance of 6% per annum. Oh, I like it. Reducing balance. Compound interest investment. Investment's going up. That's geometric growth. Perpetuity. Perpetuity, straight line. The money you earn, you're taking out. The money in perpetuity, remember, money stays the same. An annuity investment with additional payments. Annuity investment with additional payments going to go up. So B. Know your graphs? That was a fairly easy question. Next one. 4 lines of an amortization table for a new investment is shown below. The interest rate for this investment remains constant, but the payment value may vary. Okay, so here's our payment value. Even though it's 100 all the time, it says the payment value may vary. The interest earned, and so the principal addition is you're paying your 100, you're paying, and you're getting interest going towards your investment. The balance of the investment after payment 20 is 7,500. What's the value of the payment number 20? So this is what I want to find out, this one here. Okay. Don't presume it's 100. Read the question. Payment value may vary. So first of all, I'm going to work out how much principal addition. I was here. I'm now at 7,500. So first, I'm going to do 7,500 minus 7,233.83. And that equals $266.17. Right, it said in here the interest rate remains constant. So I have to work out how much the interest rate is. So I'm going to see on this amount, they get that much interest. All right, so I'm going to think La over 100 times 6977.50, and that equals 2791. I'm going to use menu algebra solve because I can. Okay, so I've typed that in, menu algebra solve for R, so our rate is 0.4%. R equals 0.4%. So I'm now going to work out the interest on this amount, and I know my interest is 0.4%. So I'm going to do 0.4%, so over 100 times the amount. Put that one in my calculator, and I get 28.93. So now I can work out how much the payment is. This is my total addition, principal addition here, 266.17. I now know my interest was 28.93. So how much did I have to put in? So I'm going to do 266.17 minus 28.93 equals 237.24. So the answer is D. Last question in the section. Xavier borrowed $245,000 to pay for house. For the first 10 years of the loan, the interest rate was 4.35% compounding monthly, and Xavier made monthly payments of $1,800. After 10 years, the interest rate changed. If Xavier now makes monthly payments of $2,000, he could repay his loan in a further 5 years. What is the new annual interest rate? So it's the last question in the section. It's got two parts to it. We've seen this a few times. So let's work out first 10 years. Okay, Xavier borrowed 245, so that's his present value, positive because it's in his pocket. 10 years, so 10 times 12 because it's monthly, rate 4.35. PMT, his monthly payments are 1,800, it's coming out of his pocket, so it's negative. I want to find out what his future value is. So I'm going to put that in my calculator and I get my future value being negative because he still owes it, 108,219.16. Still owes it. It came up as negative. Just means he still owes that amount. So now I'm going to see what happens now. So what happens in the next 5 years? Well, 5 years, I'm going to have 5 times 12. The new interest rate, that's what I want to find out. His present value is what he still owes, 108. Even though it came up as negative over here, it's his present value. So it's 108,219.16, positive value here. PMT, he's changed that to negative 2,000 because he's now paying 2,000 out of his pocket, so it's negative. Says he could repay the loan, so his future value is 0, still monthly. So I put that in my calculator and my interest rate becomes 4.142. And so my answer, B.